Hey, this is Pragya Shah, and today I am back with another book review. So, this book review is another structural geology book. This is by Haakon Fossen, again a hardcover, heavy duty book, but a really beautiful book because it's filled with colored pictures. So, I'll quickly go to the contents. You see, it's amazing. Cambridge, I think it's Cambridge publication. Whenever Cambridge publication comes with this type of a format of printing, it's a very specific format and it's lovely. The diagrams are lovely. So structural geology and structural analysis, approaching structural geology, structural geology and tectonics, structural data sets, field data, remote sensing and geodesy, DEM, GIS and Google Earth, seismic data, experimental data, numerical modeling, other data sources, organizing the data, structural analysis, concluding remarks. Deformation. What is deformation? Components of deformation. System of reference. Deformation detached from history. Homogeneous and heterogeneous deformation. Mathematical description of deformation. One dimensional strain. Strain in two dimensions. Three-dimensional strain. The strain ellipsoid. More about the strain ellipsoid. Volume change, uniaxial strain compaction, pure shear and coaxial deformation, simple shear, subsimple shear, progressive deformation and flow parameters, velocity field, flow apophysis, vorticity and WK. Steady state deformation, incremental deformation, strain compatibility and boundary conditions, deformation history of from deformed rocks, coaxiality and progressive simple shear, progressive pure shear, progressive subsimple shear, simple and pure shear and their scale dependence. General three-dimensional deformation, stress versus strain, strain in rocks, why perform strain analysis, strain in one dimension, strain in two dimensions, strain in three dimensions, stress, definitions, magnitudes and units, stress on a surface, stress at a point, stress components, the stress tensor matrix, deviatoric stress and mean stress, more circle and diagram. Stress in the lithosphere. Importance of stress measurements. Stress measurements, reference states of stress, the thermal effect on horizontal stress, residual stress, tectonic stress, global stress patterns, differential stress, deviatoric stress, and some implications. Rheology and continuum mechanics, idealized conditions, elastic materials, plasticity and flow, permanent deformation, combined models, experiments, sorry, the role of temperature, water, etc. Definition of plastic, ductile and brittle deformation. Rheology of the lithosphere. Summary. Fracture and brittle deformation. Brittle deformation mechanisms, types of fractures, failure and fracture criteria, micro defects and failure, fracture termination and interaction, reactivation and frictional sliding, fluid pressure, effective stress and poroelasticity, deformation bands and fractures in porous rocks, faults, fault terminology, fault anatomy, displacement distribution, identifying faults in an oil field setting, the birth and growth of faults, growth of fault populations, faults communication and sealing properties, kinematics and paleostress in brittle regime, kinematic criteria, stress from faults, a kinematic approach to fault slip data, contractional and extensional structures, deformation at the micro scale, deformation mechanisms and microstructures, brittle versus plastic deformation mechanisms, brittle deformation mechanisms, mechanical twinning, crystal defects from the atomic scale to microstructures, folds and folding, geometry descriptions, folding, mechanisms and processes, fold interference patterns and refolded folds, folds in shear zones, folding at shallow crustal depths, foliation and cleavage, basic concepts, relative age terminology, cleavage development, cleavage, folds and strain, foliations in quartzites, gneisses and mylonite zones, lineations, basic terminology, lineations related to plastic deformation, lineations in the brittle regime, lineations and kinematics, boudinage and pinch and swell structures, geometry, viscosity and strain, asymmetric boudinage and rotation, foliation boudinage and the strain ellipse, large scale boudinage, shear zones and mylonites. What is a shear zone? The plastic, ideal plastic shear zone, adding pure shear to a simple shear zone, non-plane strain shear zone, mylonites and kinematic indicators, growth of shear zones, contractional regimes, contractional faults, thrust faults, rams, thrusts and folds, orogenic wedges, summary, extensional regimes, extensional faults, fault systems, low angle faults and core complexes, ramp flat, ramp geometries, foot wall versus hanging wall complex collapse, rifting, half grabens and accommodation zones, pure and simple shear models, stretching estimates, fractals and power law relations, passive margins and oceanic rifts, orogenic extension and orogenic collapse, post orogenic extension, strike slip, transpression and transtension, strike slip faults, transfer faults, transcurrent faults, development and anatomy of strike slip faults, transpression and transtension, strain partitioning, salt tectonics, salt tectonics and halokinesis, salt properties and rheology, salt diapirism, salt geometry and the flow of salt, rising diapirs processes, salt diapirism in the extensional regime, diapirism in the contractional regime, diapirism in strike slip settings, salt collapse by castification, salt decolma, balancing and restoration, basic concepts and definition, restoration of geologic settings, restoration in map view, restoration in 3 dimensions, backstripping, a glimpse of a larger picture, synthesizing deformation phases, progressive deformation, metamorphic textures, radiometric dating and PTT paths, tectonics and sedimentation. So that is all about structural geology. Haakon Fossen. Hope you like this video. Stay tuned for more. This is a lovely book. If you love in structural geology, you would love to read this book. Read it as a textbook, read it as a reference book, whatever. But this is a lovely book to read. See you in the next video.